All right, first question we have is a basic antiderivative integral question. Make sure that you do not pick ln x for something like this. Ln of x is only for the integral of 1 over x dx. Now you could have like a 3 up here or 4 up here, but it's only if we have x on the bottom in the denominator, like x to the first power. So if you have x squared, it's not going to be ln of x squared. What we have to do is we have to rewrite this as x to the negative second power. Then you can go ahead and add 1 and divide by our new exponent. So that's x to the negative first over negative 1 plus c. And then this would become 1 over negative x to the first plus c, right? Whenever we have x to a negative power, we can move it to the bottom, make it positive. And then that negative just kind of came out to the front. And actually, they didn't even write it like this. They just brought the negative up and they wrote negative x to the negative first plus c. All right, our next question, we have more of a geometry question. Anytime we have these graphs of f and we need to do some kind of an integral, that's going to be the area under the curve, right? And so they say, which of the following is the greatest? So we're starting off at -2. This is kind of like our reference starting point. So for a, that would be like having the integral from -2 to -3 of f of t dt. So that's going this area, but we're going left to right, right to left, because we're going from -2 to 3. So this is actually a negative area because we're going backwards, right? That would be like the negative integral from -3 to 2. All right, g of -2, that's going to be the integral from -2 to -2. That's 0. So that's 0. This was negative, right? We want the greatest, so those aren't going to be our answer choices. Next up for c, we have the integral from -2 to 0. So it's going to be this area here. And that is a positive area, right? But when we look at d, d is going to be even a little bit more positive. D is going to be this area plus this area, right? The integral from 0 to 1. So this is going to be kind of that area plus a little extra. And then for for e, g of 2, what's going to happen is if we go from 0 all the way to 2, we're going to have this area. But then we're also going to have this negative area. And so that's going to be smaller. Now, you could actually do the math if you wanted to. I didn't. I just kind of looked at them and compared. But you could always do the math on these. And if you do that, you'd break these up into shapes, right? So you would get a rectangle, triangle, triangle here. Actually, probably do this. Triangle there, triangle on the right, rectangle on the bottom. And so you could do out the math. And if you do that, area of a triangle is base times height times a half. And area of a rectangle is just base times height. And so if we did that, we would have gotten -1.5, 0. This would have been 3. This would have been 4. And this would have been 3. So you can see that d is the greatest. All right, next up we have another kind of question with which has the least value, but this time we're talking about over-under approximations. So I think I had mentioned this in class, but the integral from 1 to 3, this is the exact area. So that's never, ever, ever going to be the least. And then midpoint and trapezoid, they're always a lot more accurate than left or right. So either left or right, those are always going to be our most extreme. So these are never going to be the least. So you got a 50-50 shot. The way I do this, I don't even worry about the number. I just say, okay, a left hand, I'm going to start on the left of this, make a rectangle that's going to be greater than. So that's actually going to be our biggest value. And for right hand, I would start on the right side, go backwards, make a rectangle. This would be our smallest value. So our right hand is going to be our answer choice. All right, one other thing just to note, a trapezoid here, just because you may run into that. A trapezoid would be an under approximation, right? So if they asked you to like rank these, sometimes they ask you to rank them in order from like smallest to greatest, and they wouldn't use midpoint there, but it would go that our right hand Riemann sum would be the smallest, then our trapezoid would be the next smallest, then the exact value, that would be the just integral from 1 to 3 of f of x dx. And then our biggest, we said, was our left Riemann sum. All right, this is one of those property questions. We want to figure out the integral from -5 to 5 of f of x dx. It's multiple choice, so you don't have to write all of this out, but I like to just for the practice. So we're going to start at -5. That needs to be our bottom number. Now, I see -5 here. I can go from -5 to 2 of f of x dx. And so if I've gone from -5 to 2, then this number needs to start down here. And so I have 2 here. 2 and 5 works, but this is going to be flipped. So the integral from 2 to 5 of f of x dx, realizing that this one is flipped. So this is -17 plus -4, right? Because we had to flip it since our endpoints changed. It's going to just be +4, which -17 plus 4 is -13. All right, next, if g of x is an antiderivative for f of x and g of 2 equals -7, then g of 4 is what? So the way we always want to set this up is when we have these antiderivatives, these are our limits. These are x, our x1 and our x2. Those are going to be our limits. It's going to be the integral from 2 to 4 of g of x, of f of x, is going to be equal to, so the antiderivative of f of x is g, so it's going to be equal to big F, which we're calling g, so g of 4 minus g of 2. So this is going to be the integral from 2 to 4 of f of x dx, and a lot of times they use t here. The reason they use t is just so we have a different variable than x. Equals, so g of 4 we don't know, minus g of 2 is -7, that's going to be +7. So we're going to subtract 7 to both sides, and that's going to give us -7 plus the integral from 2 to 4 of f of t dt is equal to g of 4. So it's choice E. All right, next up, this one you just have to memorize. The integral antiderivative of sine of x is negative cosine of x. So this is going to be negative cosine of x from 0 to pi over 4. That's going to be negative cosine of pi over 4 is rad 2 over 2. You have to memorize that chart. Minus negative, and then cosine of 0 is 1. So that's going to turn into a positive. So it's negative rad 2 over 2 plus 1 is choice D. All right, we have the regions bounded by A, B, and C shown in the figure above. And it says if the area of each region is 2, then what is the value from -3 to +3 of f of x plus 1? What we want to make sure we do on this is separate this. So -3 to 3 of f of x dx plus the integral from -3 to 3 of 1 dx. What a lot of students will do is they'll see like this side is the areas under the curve. So this side is going to be for A, it's going to be -2. Then for B, it's going to be +2. And for C, it's going to be another -2. And so they'll get -2 for that area. And then they'll just add 1 and they'll circle choice B. But that's not correct. We're adding, this 1 is inside the integral, which means we're not adding 1, we're adding the integral from -3 to 3 of 1. So what we need to do there is take the antiderivative, that's going to be x from -3 to 3. And that's going to be 3 minus -3. All right, so that's going to be -2 plus 3 plus another 3. That's 6. 6 minus 2 is 4. All right, we have the data for the acceleration of a car from 0 to 6 are given in the table above. If the velocity at time 0 is 11 feet per second, then the approximate value of the velocity at time 6, computed using a left-hand Riemann sum with 3 subintervals, is what? Now, this one is a little bit tricky because they tell us this starting value at time 0 is 11. This one has to do with the FTC. So basically what's happening is we have acceleration. If you think about position, velocity, acceleration, we have acceleration. To go up the table, we need to take the integral. So this is going to basically tell us that the integral from 0 to 6 of the acceleration will equal to v at 6 minus v at 0. Now for this integral, they want us to do a left Riemann sum. Right, that's what they told us. But what's going to happen is this is going to equal to v of 6 minus 11. So basically, after we do the Riemann sum, we're going to have to add 11 over. So in order to do our Riemann sum, this is a distance of 2. We're multiplying by the left. So that's 2 times 5 Then this is another distance of 2. We're multiplying by the left, so plus 2 times 2. Then we have another distance of 2. We're multiplying by the left, so plus 2 times 8. So it's going to be 10 plus 4 is 14, plus 16 is 30, equals v of 6 minus 11, but it's not 30 because we have to add that 11, and so it's 41. All right, the acceleration of a particle moving along the x-axis at time t is given by a of t equals 6t minus 2. If the velocity is 25 when t equals 3 and the position is 10 when t equals 1, then the position x of t is equal to what? So this is another question where, again, we have position, velocity, and acceleration. They're giving us acceleration, and we want to go up the table back to position, so we need to take the integral. We're actually going to have to take it twice. So we're going to write out a of t equals 6t minus 2, and we want to take the integral of both sides, so integral dt, and a of t is going to turn into v of t. This is going to be 6t squared over 2, it's 3t squared, minus 2t plus c. And they told us that the velocity is 25 when time is 3. So we can say 25 equals 3 times 3 squared, minus 2 times 3 plus c. That's 25 equals, this is going to be 27 minus 6. That's going to give me 21 plus c. That's going to give me 4 as my c. So it tells me that v of t is equal to 3t squared minus 2t plus 4, right, for that c. I'm going to go ahead and write this up here. V of t equals 3t squared minus 2t plus 4. And then we'll do the same thing. We're going to take the integral with respect to dt, the integral with respect to dt. So the integral of v of t is going to be x of t. It's going to be 3t cubed over 3 is t cubed, minus 2t squared over 2 is minus t squared, plus 4t plus c. So now they tell me the position is 10 when time is 1, so 10 equals 1 cubed minus 1 squared plus 4 times 1 plus c. Those ones cancel out. 10 equals 4 plus c. Subtract the 4. 6 is my c. So our answer is x of t is equal to t cubed minus t squared plus 4t plus 6. All right, we have f and g as continuous functions. Which of the following must be true? This is basically asking about if you memorize those properties. So there is no multiplication property. This one's wrong. There's no multiplication or division property. There is an addition property. So if you add f of x and g of x, you can separate those integrals. And then there is also no exponent property. And so c, number 3 is like a radical function. So it's basically like an exponent. So it's like the integral from a to b of f of x to the 1/2 power. And they're saying that you could do the entire integral first and then raise it to the 1/2 power. That's not true at all. That's not how integrals work. So remember, some of the other properties were like the integral from a to a is 0. One property that you could see is like if I had k f of x dx, you can pull the k out and make that k times the integral from like a to b of f of x dx. That would work, but there's no exponent property and there's no multiplication property. There's also no division property. Next question. This was a calculator question, but honestly, you don't need a calculator. I think it was just a calculator question because it takes a little bit longer. So this one, when you see this big F of 3 minus big F of 0, we're given the graph of f. That should be a hint to you that we're doing FTC, we're doing an integral. So the integral from 0 to 3 of little f of t dt would equal big F of 3 minus big F of 0. So basically, this was just a really tricky way to ask you, can you take the integral from 0 to 3? So the integral from 0 to 3 is this section, and the problem is this part's curved, so we can't find that integral. Like, there's no way, basically, if I color coordinate this, there's no way to find that red area. The blue area is easy, that's just a rectangle. But they tell us what that red area is. So they're telling us this red area is 2.3. So basically, this is like having the integral from 0 to 3 of f of t dt. This one of those properties would be the integral from 0 to 1 plus the integral from 1 to 3. You don't have to write this out, you could just do this in your head. But basically, this was that red section, this was that 2.3. And then this was that blue section, which is a rectangle, so it's 1 times 2. So it gives you 2 plus 2.3, which is 4.3. All right, again, this is a calculator question, but you don't really need one. So a table of values is shown here. If your subintervals from 0 to 2 are used, which of the following would be the trapezoidal? Sorry, 4 subintervals are used from 0 to 2. So a calculator is nice just to do it faster, but this is 0.5 times, for trapezoid, we do both the left and the right. So 3 plus 3, and then we divide by 2. Plus we have another 0.5. And then we do the left and the right, 3 plus 5, divide that by 2. Then another 0.5. And then we do the left and the right of that, 5 plus 8, divide that by 2. And finally we have a last 0.5. And then 8 and 13 divided by 2. And so this, you would just type that whole line into your calculator. And so you should get something like this, which gives us the answer of 12. If you're good with factoring, you could notice that you could factor out a 0.5 from everything, and you could also factor out a 2 from everything. 0.5 times 2 just cancels out to 1. So it's really just 3 plus, let's see, would that work? Oh, that's my fault. 0.5 and 3 don't cancel out to 1. 0.5, and then it's divided by 2. That actually makes 0.25 or 1/4. So 3 plus 3 is 6, plus 3 is 9, 14, 19, 27, 36, 35, 48, and then 48 divided by 4 is 12. So you could do that. I think it's a little more tricky. I would just stick with the formula. So we got 12, and that's choice B. All right. We have the graph of a linear piecewise function. What is the value from -1 to 4 of f of x dx? This is just the area under the curve. So from -1 to 4, I'm going to break this up into a triangle, rectangle, triangle. Those are all positive. And then a little triangle and a rectangle on the bottom. This is 1/2 times 1 times 2, plus 1 times 2, plus another 1/2 times 1 times 2. Those were all the top ones, right? 1, 2, and 3. And then the fourth one is going to be minus 1/2 times 1 times 1, because it's minus because it's below the axis, and then minus 1 times 1. Right, we're just doing base times height, or 1/2 base times height. This cancels out to 1, plus 2, plus this cancels out to 1, then minus 1/2, and then minus 1. So I'm going to do that. So that's 3 minus 1/2, that's 2.5, right? Or 6/2 minus 1/2 is 5/2, either way. All right. We have the graph f prime of the derivative of a function. The areas of the regions are 26 and 4. If f of 0 equals 2, what is the maximum value on the closed interval from 0 to 10? So when we get a maximum, that needs to be f prime of x equals to 0. But when we have an interval from 0 to 10, instead of doing a number line, we need to do that table, that chart. So you're always going to do x and then f of x, and we're going to include 0 and 10, and then any critical points. Well, the critical points we get from f prime of x being equal to 0. I don't know what these are, like if it's like what the numbers are, but I know it happens here and here. So I'm going to just call this A, and I'm going to call this B. So this is A, and then we have B. And they told us that f of 0 was equal to 2. So the way that integrals work, our integrals is just how much are we changing by. So this is just from 0, right, we add by 20. So this is going to be 22. Then next up, we're going to subtract by 6. So 22 minus 6 is 16. And we're going to add by 4. So 16 plus 4 is 20. So our maximum value happens here at 22. Right, the graph of a twice differentiable function is shown in this figure above. Which of the following is true? So they're asking us to rank these. Most every time in this case, it's going to go something negative, less than something that's 0, less than something that's positive. That's almost always how these go. So we can see for this, they're talking about f, f prime, and f double prime. Well, f of 1 is the y value, that's going to be 0. f prime of 1, that's going to be whether this is increasing or decreasing at 1. Well, the graph is increasing at 1, so that's going to be positive. Then f double prime of 1, that's going to be its concavity. This graph is concave down, so it's going to be negative. So we need the order f double prime first, right? This needs to happen first because it's the smallest. That's going to happen second, and that'll happen third because it's the biggest. So f double prime, f prime, that's choice D. All right, next up we have a basic integral question. They give us g of x. They want us to find the integral of f of x. And we know that f of x is equal to g prime of x. So basically they're saying the integral from 1 to 3 of, instead of f, I can put g prime of x dx. Now you could take the derivative and then take the integral, but you'd just be undoing yourself. What you want to realize on this is FTC. That just means it's g of 3 minus g of 1. So g of 3, I'll do this off on the side, is 3 squared is 9, minus 3 times 3 is 9, plus 4, that's going to be 4. And then g of 1, 1 squared is 1, minus 3 plus 4. It's going to be 5 minus 3 is 2. So this is, I said 5 minus 3 is 2, and I wrote 5. So this is going to be 4 minus 2, that's going to be 2. All right, we have another properties question. Now what we need to make sure we do on this question is we rewrite this first as the integral from 0 to 5 of 3 dx. Plus, I'm going to write it this way, 2 integral from 0 to 5 of f of x dx. So this 3 part is easy. That's going to be 3x from 0 to 5. That's going to be 15 minus 0, which is going to be 15. Then we're going to add on 15 to 2 times the integral from 0 to f of x. 0 to 5 of f of x. Well, in order to get that integral from 0 to 5 of f of x dx, we're going to do the properties. We're going to start off at 0, and we can go to 3. And then now we're at 3, so we need to start off at 3, and 3 goes up to 5. We don't have to flip this one. So that's going to be just 6 plus 4, which is 10. So this is 15 plus 10, which is 25. I'm not seeing that on the answer key. Oh, because I didn't double it. That's my fault. So 2 times 10, that's 20. So 15 plus 20 is 35. All right, we have a left Riemann sum, a right Riemann sum, and a trapezoidal Riemann sum. And it says which of those sums gives an underestimate. So I like to just kind of try to draw these. And left rectangle would be below. So left is an underestimate. A trapezoid is also below. So that's also an underestimate. A right Riemann sum, starting the rectangle from the right side, would be an overestimate. Kind of remembering these, if our graph is increasing, then LRAM is under, and RRAM is over. Decreasing would be the opposites, and then our graph is concave down, so trapezoid is under. Concave up would be trapezoid over. So you can memorize those, or you can just know how to draw them. Either way, it was 1 and 3 as our answer choice. All right, and then our last multiple choice, we have f prime of x equal to sine of x cubed. At what value does x attain its maximum on this closed interval? This is a really good question to make sure you know how to do. This is an absolute maximum. Even though it doesn't say absolute, whenever it gives us an interval, it's going to be an absolute. So what we have to do is we have to take f prime of x, set it equal to 0, and then we need to find the values here at 0, 2, and our critical point. Now this question is a little bit tricky because it doesn't give us a starting value, and so we're going to have to kind of figure it out a different way. And I'll talk about that in a minute, but before we do that, I'm going to jump over to the calculator section. And so one thing we can do is we can use that solve button. So we can do the sine of x cubed. And we got to remember when we do sine of x cubed, we set this equal to 0. If you do not put an interval, you're going to get like this weird thing with an n. So you always, if you get that, just a reminder, you have to include that interval. And they gave us the interval was from 0 to 2. You don't need to include the endpoints here, so you can just do this less than, because we don't need to worry about endpoints. They're already going to be included in our table. So this gives us 1.4645 and 1.845. So I'm going to hop back over to our paper and put those in here. So 1.4645 and 1.845. And so 8453, I guess. So had we been given something like f of 0 was equal to 2, what we would do, and we weren't given this, but had we been given that, we would do something like this. The integral from, well, this would be 2. So the integral from 0 to 1.4645 of f prime of x dx equals f of 1.4645 minus f of 0, which is 2. And then we would just add the 2 to both sides. And we could type this into our calculator, add it by 2, and that would go here. And we would just keep repeating that process. But they didn't give us anything like this. So that makes this really kind of a trickier thing. But we do have a graph. So if we come back over to the graph, what I can do is... Okay, so I unintentionally paused this video. I'm not sure exactly what I said last. So there might be kind of a weird jump here. But I do want to make sure I just fully explain this. So another way to look at this is to do a number line, since we can't actually find out our values. And so if you kind of make a number line here, we have 0, we have 2, we have 1.4645, we have 1.8453. So this graph, if we look at it, is above the axis, right? This is an f prime graph. So if we look at our graph, we are above the axis first, then below the axis, then above the axis. So this is going to go plus, minus, plus. So we're going to increase, decrease, and then increase. So 0 and 1.8, those are minimums. And we don't know if 1.465 is taller or if 2 is taller. We're just not sure. But what we can kind of do is look at the areas. So if we look at this area, here we went up and we reached some point. We don't know what it is. It could be 10, it could be 20, it could be 30, it could be 4, we don't know. But then from there we go down by this amount, and we come back up by this amount. So what we want to think is, did we go down more or did we go up more? Well, we went down more. So if you just imagine any number, right? Let's say, we were at 10, you go down by some amount like 6, but then you come up by a little bit less, right? You're going to be at 8. So the original starting number was bigger because we didn't come back up to it, right? So another way you could kind of think about on here is we were up here, we went down by more than we came back up. So this point is going to be higher. So our answer is going to be C. All right, moving on to our FRQ section. We have a particle given by the velocity v of t, and then we have the position of the particle by s of t. And we know that s of 0 is equal to 10. So A, find all the values of t in the interval from 2 to 4 for which the speed of the particle is 2. Now, this is a calculator section. This is a little bit tricky, but we basically just need to know about speed, right? That speed is equal to the absolute value of v of t. That's the formula for speed. Now, there is the whole speeding up, slowing down thing, right? Our speed increases when v of t and a of t have the same signs, and decreases when they have opposite signs. That's for speeding up or slowing down. That's not what we're talking about here. They just want to find any time that the speed is 2. So basically what they want us to do is they want to take the absolute value of v of t, set it equal to 2. So you want to make sure that you write this down. That needs to be written down. And then from there, you can just solve everything on your calculator. So I went ahead and typed this in to save us some time. Now, the one thing that you might have forgotten about is the absolute value. The absolute value is right here. So it's that button next to the book, and then it's here in this top right corner. So I did the solve button. We did the absolute value of, oops, there we go. The absolute value of that function. And I don't know why this is kind of messing up, but let's just hit enter in. Yeah, for some reason that's in our way. Give me 1 second. So there we go. So we did the solve button. We did the absolute value of that v of t function, we set it equal to 2 comma t, and then at, they wanted between 2 and 4. And so those are our two answers, and I'm going to go ahead and write those over. We want to go out to 4 decimal points, so t equals 3.1276 and 3.4734, and those are our answers. We're just going to go ahead and box them. B, write an expression for the position s of t, and use this expression to find the position of the particle at time 5. So basically on this one, we have velocity, and we know that s of 0 is equal to 10. So the integral of v of t dt from 0, right, we're going to use 0 because it's there, to any time t is going to be equal to s of t minus s at 0. Now s at 0 is 10. So basically this is the integral from 0 to time of v of t dt equals s of t minus 10, and then we would add 10 over. And so that can be our expression, is 10 plus the integral from 0 to any time t of v of t dt is equal to s of t. So that's the first part, right? This is going to basically tell us that if we take the integral, we add on that starting value of 10, that's going to give us our answer that we want. And then they said use this to find s of 5. So s of 5 would equal 10 plus the integral from 0 to 10, 0 to 5, right? This number always goes up there, of v of t dt. So we're going to go ahead and use the calculator. And I figured I'd show this part just because it does help you to kind of speed things up. Is I can come up here and I want to have this. I don't want to retype it although because it takes a long time to type. So I'm going to hit all of this and then Control C, come down here, Control V, DT. I'm going to do Control Enter to make sure I get a decimal. And that gives us negative 9.2073. Next up, they ask us to find all the times from 0 to 5 where the particle changes direction. So whenever we see changes direction, that's when v of t is equal to 0. That's when it comes to rest. Now, changes direction is kind of like an inflection point where it does actually have to change. So we're going to want to test those. But the first thing we're going to want to make sure we write out is we're going to want to write v of t equals to 0. Now that we can do on our calculator, we can use the solve button. So I'm going to come back to our calculator, and we're going to go to Menu, Algebra, Solve, and then I think I still have that pasted, so I can do equals to 0 from, or comma t, and then from 0 to 5. Now there's actually an easier way to do this, and I'll show that in a second, but 0 less than t less than 5. And then we'll hit Control Enter. Now, what did I mess up? Solve. Oh, I didn't put the at correctly. All right, that needs to be Control at 0 less than t less than 5. There we go. So I get 0.536 and 3.3177. Now we're actually not sure if we did change direction at each of these points, but I'm gonna at least write these down for now. So it's going to be t equals 0.5360 or 3.3178. Now you can make a number line, and you can kind of do a number line from 0 to 5 and throw these in here. And then you can test out points by plugging them in. But a little bit easier than making a number line would be to just put this on the graph. And I think that's way easier. So I'm going to do that. I'm going to come over to our graph. And let's get rid of this old guy. Control delete, Control V, let's see if that's still there. No. All right, Control delete. is giving me some issues. All right, I'm going to just go Menu, Actions, Clear All. And so what I want to do is I want to come back here, same kind of a thing. I want to grab this. You would use Shift and the left button, Control C. Come back over here, Control V. Now the one thing you do want to make sure is all of these X's, you need to change them to times. This was X squared. Sorry, the X's you need to, the T's you need to change to X's. I think I misspoke on that one. So it needs to become an X. Okay. So, X cubed. All right. So now we can go ahead and graph this, and we need to make sure our window is correct. We're now going from 0 to 5. Okay, so we do see that it does change directions. So then on that number line, we're going to put negative, positive, negative. And so now we can say V of t changes directions. Or not V of t, but the particle. The particle changes directions. At t equals 0.5360. Comma 3.3178. Now they want us to justify this, so we're going to just say because V of t changes signs at those points. Now it's always a good idea to label your number line, so I'm going to put a V here. All right, and then finally we have D is the speed increasing or decreasing at time 4. I'm going to kind of put this in here. We already talked about that. That's checking the signs. So we want V of 4. And we want A of 4. And we're going to get these on our calculator. So I'm going to pop back to our calculator. And again, we'll grab this. So this is going to be our V of t. And we want this at time 4. Actually, you know what I'm going to do? I'm going to do this. I'm going to go V of t, control equals, so this will give me V of t there. So then I can do V of 4, and I'll hit control enter. So that's negative 11.47, and then I can do the derivative. So we can do the derivative with respect to time t of V of t. This will give us A of t. Right? And so then I can do this guy at time 4. It probably would have been easier to just do, actually, to kind of do this. The derivative of time t of V of t. Right? Not V of 4, because if you do V of 4, you're taking the derivative of negative 11. That would be nothing. And then outside the parentheses at time 4. Negative 22. So they're both negative. Now you can't just go in and on your FRQ, you can't just say the speed is increasing because they're both negative. You need to write these out. You did them on the calculator, they can't see your calculator, so you need to write them out. So this is less than 0. And then negative 22.2957, that's also less than 0. So we'd say the speed is decreasing at time equals 4 because V of 4 is less than 0 and A of 4 is less than 0, meaning they have the same signs. Okay, our next FRQ is a table question. First off, they want us to use the data in the table to approximate C prime of 3.5. So anytime we're approximating a derivative on a table, that's always f of b minus f of a over b minus a. Now 3.5 would be about here. So we're going to go C of 4 minus C of 3 over 4 minus 3. It's going to be 12.8 minus 11.2 over 4 minus 3. We can use our calculator for that. And we are going to get 1.6. Right. One thing to watch out for on your calculator, by the way, is if you're doing a new problem, it's always a really good idea to be using documents. I was on the Scratchpad, I was being lazy. But if you're on documents, then you can go back to those old questions and you don't have to worry about these. If you're lazy like me and you don't do that, a good idea is to go to Menu, Actions, Clear A to Z. That's going to clear out that V of 4. And then you'd also clear the history if you want, but I'm just going to make sure I do that. That way now if I have a V in my question, I type in V of t, it's no longer linked to this old problem and I won't make any mistakes. So coming back here, we got 1.6. Now, they say show your work and indicate units of measure. Well, anytime we take a derivative, that adds on a per time. So we had ounces, we took a derivative, so it's going to add on per minute. All right, next B, is there a time when we see this? I'm thinking IVT, MVT, or rolls, where C prime of t is equal to 2. Now C prime, that's going to be either MVT or rolls, and it's to 2, so that's MVT. So if we come back up here, we see that C is differentiable. So C is differentiable, so it's also continuous, which means that MVT applies, so we can use it. Now we still have to make sure that it's going to work, but it does apply. So is there a time where C prime of t is equal to 2? Well, C prime of t, what MVT basically says is we're going to set the derivative equal to C of, let's say, and we're going between 2 and 4, so C of 4 minus C of 2 over 4 minus 2, right? That's what MVT wants. MVT wants a time where the instantaneous rate of change equals the average rate of change. So let's go ahead and kind of work that out. So C prime of t equals C of 4 is 12.8 minus 8.8 over 4 minus 2 is 2. You can use your calculator, but you can also just see 12 minus 8 is 4. 4 divided by 2 is 2. So yes, right, that's what we wanted. So we'd say yes, by MVT, there is a time such that C prime of t equals 2 because C prime of t equals C of 4 minus C of 2 over 4 minus 2 equals 2. You probably don't need that because you already showed all the work, but I'm going to add it. All right, C, use a midpoint sum with 3 subintervals to approximate the value of 1/6 integral from 0 to 6 of C of t dt and explain that meaning. Now, next semester, this was actually, I didn't catch this, this was from the second half of chapter 6, so I'm going to just get rid of that 1/6. Next semester, we're going to learn something special with that. So let's just get rid of that for right now. So our integral from 0 to 6 of C of t dt will be approximately, and then we want to have 3 subintervals and a midpoint. So this is 1, 2, 3. That's 2, that's also 2, and that's also 2. And our middles, right, so it's going to be 2 times 5.3 plus 2 times 11.2 plus 2 times 13.8, and we'll use our calculator to get that answer. And we're going to get 60.6. And then explaining the meaning, so derivatives are always the rate of change, and integrals are the amount of change. So this would be the amount of change of, now this is a little bit tricky. I'm going to actually get rid of this. This is kind of why they have the 1/6. It's always the amount of change of whatever is kind of above it, but there's nothing really above ounces. So we're going to just kind of stop right there and just kind of practice taking that integral. Right, D, the amount of coffee in the cup in ounces is modeled by B of t equals 16 minus 16 e to the negative 0.4 t. Using this model, find the rate at which the amount of the cup, amount of coffee in the cup is changing when time equals 5. So they're saying the amount is modeled by this function. Find the rate. Well, all this is just b prime of 5. Not too bad. So you'll just type that into your calculator. We'll hop over. And so we want to do the derivative with respect to time. And then we're going to just write this out. So we type that out, and then you get 0.86614, and so that's what we're going to write out for our answer. Right, and this would be in ounces per minute, again, because it's a derivative. All right, next we have this kind of area question. Find all the values for which we have a local minimum. So the first thing we always want to do is say f prime of x is equal to 0. That's going to happen at 1, 2, 3, 4, and 6. Now, those aren't all going to be local minimums. It's only going to be a local minimum where we change directions. So this is going from 0 to 8, by the way. So we have f prime, 1, 4, and 6. We're above the axis, so positive, positive, negative, and positive. So our answer would be a local minimum is only at 6. Right, so f has a local minimum at time equals 6, or x equals 6, because f prime of x changes from negative to positive at x equals 6. All right, B, determine the absolute minimum. So we already found f prime of x equal to 0. So we have x and f of x, and we're going to put in 0, 1, 4, 6, and 8. And then they gave us that f of 8 was 4. So we know f of 8 is 4. So to find the rest of these, there is kind of a shortcut. But basically, the long way of doing this would be the integral from 0 to 8 of f prime of x dx equals f of 8 minus f of 0. Now, to find this integral, that's the areas. This would be 2 plus 6 minus 3 plus 7 equals 4 minus f of 0. 2 plus 6 is 8, minus 3 is 5, plus 7 is 12. Subtract the 4, we get 8 equals negative f of 0. So we get negative 8 here. Okay. Now, what you can also do that's a little bit quicker is if you kind of realize, hey, this at f of 8, our answer is 4. Well, going backwards, that means we would subtract by 7. So that would mean this would have to be negative 3. Going backwards, that would mean we would add by 3 since we're going backwards and it's below. So that would be at 0. Going backwards, we would subtract by 6. That would be negative 6. And then going backwards, we would subtract by 2. That would be negative 8. So we want the absolute minimum value. That's going to be that value here. So our absolute minimum value is negative 8, right? And that's at x equals 0. All right, C, on what intervals is this graph both concave down and increasing? So in this case, I'm going to make a number line for f prime of x. So we had 0, 1, 4, 6, and 8, and we had positive, positive, negative, positive. And then I'm going to make one for f double prime of x. Now, for f double prime of x, where are possible inflection points? Well, that's going to be at any local extrema on f prime. So f prime, f prime, f prime, right? And kind of there, but that's an endpoint, so we're not going to really worry about it. So that's where our graph of f prime changes from increasing to decreasing, which is where f would change from concave up to concave down. So here, f prime is decreasing. That means f is concave down. Then in between these 2 points, f prime is increasing. That means f is concave up. Then f prime is decreasing. F is concave up. And then f prime is increasing. Oops, that's concave down. F is concave up. So those points are 1, 3, and 5. I'm going to kind of draw these in the middle. And so we went concave down, concave up, it kept switching, right? Positive, negative, positive, negative. So we wanted to know where is this graph both concave down and increasing. So concave down is here and here. And we wanted to know concave down and increasing. Well, this graph is increasing and concave down there, and then there. So it's going to be f is concave down and increasing for 1, 2, 3, union, let's probably do this, union 6 to 8, because f prime of x is greater than 0 and f prime of x is decreasing for those values. Now, another way to think about this would actually be to just abandon the number line entirely and come back up here. And this may actually be a little bit easier for some of us to think about, is I know we want concave down and we want increasing. So for concave down, where do we get that on an f prime graph? Well, concave down on an f prime graph is when f prime is decreasing. And where is our graph increasing? It's when f prime is above the axis. So where is this graph above the axis and decreasing? Well, from 0 to 1. And then from 1, 2, 3, 3 to 4. And I think it's, all right, concave down and increasing, yeah. So I may have actually even messed this up. Let me see. Yeah, I messed this up because I flipped these. This was negative, positive. So I'm glad I actually showed that. So this was negative, positive, negative, positive. So this would have actually been, right, concave down, and increasing would have been here and here. So it's actually from 0 to 1 and then 3 to 4. Okay, so again, I think that the best way to look at this is just to realize, hey, concave down, that means f prime is decreasing, and then increasing, that means f is above the axis, and so that happens in these two sections, from 0 to 1, and then from 3 to 4. All right, and then lastly we have d, and d says the function is given by g of x equals f of x all cubed. If f of 3 is negative 5 halves, find the slope of the tangent line for g at x equals 3. So the slope of the tangent line, that just means find the derivative. So that's g prime of x at x equals 3. Well, g prime of x is going to be, it's going to be chain rule, right? We're going to bring the 3 down. So it's going to be 3 times f of x squared, chain rule, times f prime of x. Well, they wanted us to figure out what g prime of 3 was. So it's going to be 3 times f of 3 squared. Well, f of 3 they gave us was negative 5 halves. So 3 times negative 5 halves squared times f prime of 3. Well, f prime of 3, right here, 1, 2, 3, is the y value because this is the graph of f prime. So the y value is 4. So f prime of 3 will be 4. So times 4. It's going to be 3 times, it's going to be 25 over 4 times 4, right? Because we're going to square negative 5 is 25, square 2 is 4. Those cancel, and we get 75. Now, had you also wanted to just box this, you would have been okay as well. Right, and then I believe this is our last, yeah, this is our last one. So we have the temperature of water in a tub, and it's another table question. W is the degrees Fahrenheit. At time 0, the temperature of the water is 55. The water is heated for 30 minutes. So A, use the data in the table to find W prime of 12, and we're going to do an estimate. That's 12 is kind of right here, so it's going to be W at 15, right? Y2 minus Y1 over X2 minus X1, or F of B minus F of A over B minus A. So this is going to be equal to 67.9 minus 61.8 over 15 minus 9. If this was a non-calculator question, you would stop here. Since it is a calculator question, we're going to type it in. and you should get 1.016 repeating. And this is going to be degrees Fahrenheit per minute. Right, the reason it's per minute is whenever we take the derivative, we add on a per time. W was in degrees Fahrenheit, so we add on a per time. B says to evaluate this integral from 0 to 20 of W prime of t. Now, the integral from 0 to 20 of W prime of t, we want to be extra careful here because they don't say it left hand, they don't say right hand, so we're not doing that, right? And we were given W. So if we don't have left hand, we don't have right hand, the only other thing we can kind of think about is that FTC, right? This is W of 20 minus W of 0. If for whatever reason you didn't think of that, what is the integral of W prime? Well, the integral of W prime would just be W from 0 to 20. This would be W of 20 minus W of 0. So if you forget FTC for whatever reason, just do that, you'll get the same thing. So W of 20 in the table is 71. W of 0 is 55. So this is just 71 minus 55. And then you can use your calculator to figure that out. And that's 16. Okay. And the units, because this is in W's, the units are just degrees Fahrenheit. Right, so what would this represent? This represents the change in the temperature of, I believe it was a tub, right? Of the water in the tub in degrees Fahrenheit. We always need units. From time equals 0 to time equals 20 minutes. Right, they asked us to explain that meaning. Okay. Next up, we have another one of these guys, and they want us to use a left-hand Riemann sum to find this average water temperature. I'm gonna just get rid of the 1/20th again. We haven't really learned that. If you put the 1/20th in, that's fine. You know, you can just take my answer and divide it by 20. But since we haven't talked about that, I'm gonna hold off on that. So we want to use the integral from 0 to 20 of W of t dt, and they want us to use a left Riemann sum. So we're gonna say this is approximately equal to, so this is going to be 4 times 55 plus 5 times 57.1 plus 6 times 61.8 plus 5 times 67.9. Right. And then we will type that all into our calculator. And that gives us 1215.8. And they want us to figure out, is this an overestimate or an underestimate? So in order to do that, let's go back and let's reread this. And it tells us that the temperature of the water is modeled by a strictly increasing function. So if we're increasing and we're doing a left Riemann sum, this will be an underestimate. So we would say this is an underestimate because W of t is increasing and we used left Riemann sum. That's all you have to say is increasing in LLM. Right? And then finally D, we have this function given by W prime of t equal to 0.4 rad t cosine of 0.06 t. Based on this model, what is the temperature at time 25? So they're saying this happens after 25, okay, after 25. So what we know is we know the water at 20 is 71. So that's, we kind of know that, right? So you had to kind of figure that out or think about that, but the water at time 20 is equal to 71. Then we want to go from 20 to 25. So basically what this would be is the integral from 20 to 25 of W prime of t dt would be equal to W of 25 minus W of 20. Well, this integral we can use our calculator for. So we're going to hop over to our calculator and do an integral from 20 to 25. And then we'll type in our function, and just be careful that you have this like times in the middle. You type it all in correctly. So we're going to hit Control Enter. That's going to give us 2.04. So that would be 2.04315 for our integral equals w of 25 minus 71. Then we just add the 71 over. That's 73.043. I'll round that to 2. And that would be degrees Fahrenheit is equal to w of 25. All right, for these extra questions, I'm not going to include those in the video. This video is already an hour long, but you guys can try those on your own.